So yesterday we started with a mass sitting on a flat surface, and mu is the ratio between the parallel force, which was 5, so we're trying to get it to move, and the perpendicular force, which is the weight, 2 times 9.8. So if it's right at the point of overcoming friction, mu would be 0.26. And one of the biggest, most common mistakes that I see beginning physics students make is getting mu confused with friction. Mu isn't friction. Mu is the coefficient of friction. Charlie, look in the, is that blank?
Yeah.
That's yours. Mu is the coefficient of friction. It's basically a number that gives you an idea as to how sticky the two surfaces are when they're together. So sandpaper would have a higher mu value. Sandpaper and like balsa wood would have a higher mu value than my sweaty palm against this desk. Okay?
I don't know, maybe you're wrong.
It could be. But do you get the idea here? That's just a number value that gives you an idea as to how sticky the two surfaces are. It's not the force to overcome friction. The force to overcome friction is going to be dependent upon how sticky the surfaces are and how heavy the thing is that you're pushing. So let's say I have a very small and light piece of balsa wood on this table, and I push that, and I have a much heavier, also balsa, piece of wood on the same table. The mu values would be the same, right? It's the same balsa wood and table. Stickiness. Which one's going to be harder to push? The heavy one. So it's not, the force to overcome friction is dependent on how sticky the surfaces are and how hard the surfaces are being pushed together. Okay? That's the normal force piece of it. So mu, not friction. What's mu? Coefficient of friction, which tells us what?
The ratio.
Yeah, the ratio, how sticky the surfaces are together. All right? We will practice this many, many times. All right, so we end up with a coefficient, a stickiness constant of 0.26. And then we're going to use that same mu, and we're going to make it heavier. Should it be easier or harder to push it now? Harder. So the stickiness is the same, but yes, indeed, when you solve that, you end up with 7.6 newtons to slide it. Up here, how much did it take? 5. Does that make sense? It's heavier. It's 3 times 9.8. The stickiness was the same, so this is our heavier piece of wood. It's going to be harder to push. Go ahead, Shannon.
After you get if we did the 0.26 mu, or 0.26 equals x plus 3.2 over 98 minus 1.5 equals f, to solve for f.
Yep.
What did you do next to get 7.6?
Well, this is number 2. We haven't even done that yet. This is number 2. You're jumping ahead to number 3, dear.
Okay.
Hey, let's talk about number 3.
Sorry.
No problem.
I was looking at the wrong problem.
That's okay. All right, so now number 3, we made it even a little trickier. It's the same mu, so it's the same surfaces. It's the same mass. But now we're going to pull, remember I did this in class, we're going to pull up and to the right. And we initially thought, well, that would not be helpful because you're pulling at an angle and it's not nice and parallel with the surface. Indeed, what did we find out?
Very helpful.
It was quite helpful. And why is it quite helpful to pull up-ish? It makes it what? Go ahead.
There's less weight being pulled down by gravity.
Yeah, that's exactly right. You're lightening the load. You're reducing the normal force. Okay? So now if we look at this equation, here's what we have. I'm going to push it with some unknown F force to make it just at that sweet, like Goldilocks sliding, just barely sliding spot. So F, and then 3.5 cosine 25, that's the part of 3.5 that we're using to make it slide. We're going to subtract friction. Is friction always negative?
Friction is always negative.
Friction is always negative. Can you say that for me?
Friction is always negative.
Yeah, I'm not feeling it.
Friction is always negative.
I'm still not feeling it. Thank you, Wes, though. I love you. The rest of you, friction is?
Always negative.
Thank you. Now, the reason I'm being obnoxious is that somebody in the room missed that. So that's why I made you say it. Even though, Wes, thank you. Right, and Alex, I see you. Okay. So, this whole thing now is friction. Notice what happened here. The 3.5 sine 25 did what? Yeah, it kind of reduced the weight, that 2 times 9.8. So that helped reduce friction. The 1.5 is the extra force I need to just get this block to barely start sliding. All right. So that we got that far, and then we tipped it on a hill, and then we probably need to figure out what's going on.